Okay, so we will evaluate this line integral on this given curve C. I will set it up, and since the integral, if it turns out that the integral is an elementary one, I won't do the details, but I will post the answer under the video, so you can check it out. ds is the length of the arc, which is represented by the x, y, and z given. So it will be dx over dt squared plus dy over dt squared plus dz over dt squared. And those are just the derivatives of the given curve C. So dx over dt is 8 cosine t squared. Dy over dt is just 1 squared because derivative of t is 1. And dz over dt will be 8. I'm sorry, this is a sine, not a cosine. 8 cosine t minus sine here squared, and then we take the square root. Of course, when we square those two, we have sine squared t plus cosine squared t equals 1. So after we factor the 8 squared from both of them, we will get 64 plus 61 times 64 times 1 is 64 plus 1, which is here. So we get square root of 65. So now this becomes the x is just 8 sine t times t times negative 8 cosine t. So I'm plugging into the integral x, y, z, and then ds is just square root of 65, and of course there's a dt here after the in the integral, because it's a ds, so it'll be all those multiplied by dt, and we are integrating from 0 to pi. Now this square root 80, 65, and 8 we can pull out, and we get 8 times negative 8, so minus 64 times square root 65. Now sine t times cosine t, I can reduce that to sine 2t, because that will be 2 sine t cosine t, and to correct for the 2, I could just divide that by half. So half sine 2t will be the same thing as sine t times cosine t, and of course we have another t sitting here, so we can pull the half out and we get minus 32 square root 65 t sine 2t dt. And the way this integral can be evaluated is using integration by parts. I will show this on the next page. So we have t sine 2t dt. We will call u to be sine 2t, which makes du sorry, meant to say u to be t and dv to be sine 2t, because that would give us the easier integral on the du when we plug in the formula. So this will be negative cosine 2t, the integral of sine 2t over 2, and if t is u, then du is just dt. And the integration by parts formula goes something like this: u dv, integral of u dv is equal to uv minus the integral of v du. And so now we can make the substitution back into the integral. So we are doing here by parts. So if we plug into the integral, we have uv to be minus t over 2, coming from the half, cosine 2t minus v du. Minus and minus becomes plus. The half I can pull out, and then we have cosine 2t for v, and du is just dt. And this is, of course, a very elementary integral. Cosine is sine 2t over 2. This comes down as s. And we multiply by our initial constant, minus 32 square root 65. And we can evaluate this from 0 to pi. Those steps are elementary, so I will not do them here, but I will post the answer at the bottom of the video. Thanks. Don't forget to rate and subscribe.